I lose people here. I lose people. Bless you. Guten Tag. All right. So I lose people here. Has nothing to do with bless you, but that's fine.
Good morning.
It is. It is good morning. Just so you know, I would have done that on the first day, and you all would have straight-faced me. Just so you know. You guys were like straight-facers for at least a week and a half. And John was quiet then. All right. He was for about 2 days. Maybe 1. All right. So here we have 0 of multiplicity 1. You okay? Well, we knew that. But are you like actually okay right now? Okay. So 0 of multiplicity 1 means there's only one x-intercept there. Okay? If there's only one x-intercept, how can you tell by looking at a graph? Well, they just draw through the x-intercept. So these are all zeros of multiplicity 1. So when I go to draw my graph, I go straight through it. And then this one I go straight through again because there's only one x-intercept there. Then this one I go straight through again because there's only one x-intercept there. Do you see that? So it's a 0 of multiplicity 1. Multiplicity 1 is the only multiplicity you don't have to state, because if you don't put a multiplicity, we assume that it's 1. Okay? Now what happens when you have a multiplicity 2? What is this one? A multiplicity what? 1, because I just go straight through, right? This one's a multiplicity 2. Watch yourself. So it comes down, and it hits the x-intercept, and then it hits the second one, and it does what? Bounces it back up. It's called a point of tangency. Most people forget about it. So it actually hits the x-intercept, and it bounces it back up. Okay? Let's go back to grade 11. We always go back to grade 11. Things make sense, and you'll just go like this after. Oh, yeah, that makes sense. So if you had your vertex on the x-intercept, on the x-axis, so say you had this, x minus 2 squared. That's how I have my vertex on the x-axis. Why? Because I'm moving it 2 to the right and nothing up, right? With transformations, we learned that. So that would be like this. And it's concave up. I'd have something like that. We agree? Well, how many? We actually had 2 multiplicities of our, we had a multiplicity 2 of our x-intercept, and it happened to be the vertex. Pick another color, Lepp. Okay. Happened to be the vertex. Because if I get rid of this is x minus 2 times x minus 2. It's actually in factored form, is it not? When it doesn't have a y for my vertex. So you end up getting that multiplicity 2, because it hit it once and hit it twice. Now, points of tangency can also be multiplicity any even. So multiplicity 4, 6, 8, 10, 12, etc. Plus the 2, right? Can everyone grab out their calculators, please? Okay, so we're going to just do quadratics for now, because quadratics is where you've lived last year. Okay? So if I go x minus 3 squared, I can't add anything to the back or it's not in factors form, right? So put in x minus 3 squared and press graph. And I'm going to go zoom 6 because I'm not sure what I'm at. Oh, I was. So there's zoom 6. All right. So I have x minus 3 squared. Yes? Okay. What if I go x minus 3 to the 10 now? So that means I have 10 of them there, right? Multiplicity 10. And I would make yours thicker. Remember, make your line thicker if you don't have the colors. What happened? It's still tangent. It's tangent means touches in one spot. It's still tangent, but it's just like bouncing 10 times, right? It's like bouncing up, down, up, down, up, down, up, and up, down. Because remember, every single x-intercept, it bounces, 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 right? So if I go with 10, it would be like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See how much wider it is? Because it's bouncing. This one only bounces once, twice. Sends it up because it's multiplicity 2. If it's 10, it gets wider. If it was even more than 10, say it was 16, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What if it's 17? Ooh, leading us into that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It would send it in the opposite direction, wouldn't it? So evens bounce up. Or it doesn't always bounce up. If I was coming from this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. right? It would bounce back down. It just bounced in the same direction. Okay? So it can be multiplicities of any even would get me this point of tangent C. It just gets that wider base the more you have, correct? Now, if they didn't actually give you what it is, then and they gave you a graph like that, they'll often say the least degree that you can make the equation be. So if it's the least degree that you can make the equation be, then you would pick multiplicity 2, correct? You're not going to pick 4, 6, 8, 10. So that would make everyone have the exact same equation if they say least degree. Because if I want the least degree of this graph here, then I'm picking this to be multiplicity 2, right? The smallest degree. And then multiplicity 3, how do you get that curve? It's called point of inflection. How do you get that curve? Well, you come up, straight up, then you hit it, bounce, it tries to bounce you back down like a tangent, correct? That's how you get that curve. Tries to bounce you back down like a tangent, but there's actually 3. So it doesn't bounce down, it also bounces back up. So we get the 1, 2, 3. And it just kind of runs along straight and back up. Okay, we get that point of inflection. So now, once again, multiplicity could also be, instead of 3, it could be 5, 7, 9, 11, 13, etc. So we're going to go back to our calculators once you have that down. When you have it down, pick up your calculators, because then I know you're ready. So if I use multiplicity 3, 5, 7, 11, whatever, 9, 11, I can't show you with the quadratic because it's too small. So let's do a cubic. A cubic, I could just go like this. I could go x minus 3 cubed. And that is the same as x minus 3 times x minus 3 times x minus 3, right? They're the same thing, are they not? One's just a short form of the other. And I get that point of inflection through it. Okay? Now, what if I change this to a 9? Now I have 9 of them going through there. It's just going 1, 2, 3, 4, 5, 6, 7, 8, 9, sending it up, right? So it makes this wider in here. The red is the cubic, the blue is the 9. We go up to degree 5, so they won't go up to 9, but it's something to know when you go into further mathematics, right? So how could they give me a cubic mixed in with something that's not? Well, I can do this. I can go x minus 3 cubed, and then add another x plus 4, let's say. What degree is this one? 4. It's degree 4. I have 3 plus 1, it's degree 4, right? We've talked about this. If it's a degree 4 at maximum, you can have 4 factors, 4 linear factors. But no matter what, all of your factors have to get you the degree of what you started with, right? So if you have all linear factors, you're going to have 4 if it's a degree 4. If you have all linear factors and it's degree 5, you're going to have 5. The only way you can have less than 5 is if one of them is a quadratic factor, right? If it's a degree 2. So, let's graph. Through negative 4, it's going straight through, and then it's coming down here. Oh, it's way lower. Yeah, I was going to go negative 150. Still can't see it. So then if I'm you guys, I go negative 10,000 now. You're like, that's what you do. Negative 50, negative 55, negative 100, negative 1 million. I'm like, how did you jump? Like, that's not even exponential. That's like ridiculous. So please don't do that.
Negative 300.
I'm a rebel. Okay, so this goes here, goes straight through, then here it curves and goes back up, right? So this one here is going to have 3 at it. This one's going to have 1 at it. Now wait a second, this is x equals negative 4, this is x equals 3. Let's look back at our equation. This is x minus 3, this is x plus 4. Why is it opposite? Because if those are x-intercepts and these are, what's this here? Those on the graph are x-intercepts, what are these? Starts with an F.
Factors.
Factors. There we are. So when we work our swell, yep. So I'm going to add swell to my notes. So I'm writing swell, so you all can write it. That's actually, it's a PH, swell, with a silent A at the end. And an accent. I'm going to go E. Okay. That E at the end, so that's completely the E silent. But if you want to throw an at the end, you can. Okay. So what we do is we take it and we you take it and you put you set your x-intercepts equal to 0 and work backwards. Correct? All right. Let's go back. Here we are. Okay, guys. What do you suppose this graph could be? Degree what? Could be degree 3. Why? This has how many at it? This has how many at it? Could this also have 4 though? So could this be degree 5 as well? Yes. You add your number of x-intercepts. This has how many x-intercepts through it? 1, because it goes straight through, right? And this one has how many factors? 2, because it goes up and then comes back down. So 1 and 2 is 3, so it could be degree 3. This one could also be a multiplicity 4, though, we said, right? So it could be degree 5, but then we would stop there. This one is a degree 3, because that just goes up and down. It doesn't stretch a bit, right? Okay, let's talk about it this way. So what's the least possible degree this one could be? Can't be degree 2. I'm asking the graph, guys, not the x-intercepts. The whole entire graph, what degree could it be? Lowest. 3. Why? Because this one has a multiplicity. Go straight through. So it's a multiplicity 1. Because we're asking for least, right? That also has to be a multiplicity 1. And then what's the least degree of the tangent? I mean, least multiplicity. There we go. Eventually we'll get all light bulbs. A whole bunch of light bulbs.
Holy crap, that makes sense.
So, if you're not there, you'll get there. Trust me. We're not done the question. I've literally just wrote down 2 things. So if you're a little lost, I understand, because I've taught you barely anything. Okay. So if I add this one up and this one, that's a degree 3. Let's talk about it in factors. Actually, let's talk about it in x-intercepts. So what are the x-intercepts? X equals what? -4. Do I have to write multiplicity 1 behind it? You can, but that's the only one you do not have to write. If you don't write anything, we assume it's multiplicity 1.
Would you have to write it as a coordinate if you just x equals -4?
If you write multiplicity, you do not have to write it as a coordinate. But I will, if I see x-intercept on a diploma, I will always go this behind it. Because I am not a rebel. And I want them to not be allowed to take any marks off of me. I will cover every single basis that could possibly happen. Now my other x-intercept is 1. But it's multiplicity 2. And then I just go 1, 0 to help myself out. Now, you guys came up with equations last year. You totally came up with equations last year. So this one's a multiplicity 2 because it bounces, right? Up 1 and then 2 sends it back down. Do you see that?
Yeah.
That point of tangency gets you at minimum 2. Everyone agrees? Okay, if we want to determine an equation, we can just always do our equations in factor form, right? We don't have to do them in a different form. If they want it in this form, look at me. Everyone's paying attention. Put your pencils down. I will lose all of you in the hand, and you'll be like, I can't do these. And I'll be like, remember when I told you to put your pencil down at approximately 14:25 on October 4th? If they ask for this, if they ask for it in that form, you can never go directly to that form, ever. And then you'll pull me over and you'll be like, Mrs. Lepp, how do I go right to this form? And I'll be like, remember, October 4th at approximately 14:47. We went over this again. You can never go directly to that form. Ever, 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 ever. Never, ever. No. Can't do it. Don't do it. Don't try it. No. You have to do factored form. Okay? That was really exciting out there. Unlike this class. It's not very exciting, but that, very exciting. I just like watching to see who's going to be very excitedly walking past. Okay. So, we want factored form. Okay? Ready? If x equals -4 is my x-intercept, what is my factor? How did you do that? You went x minus 4, x equals, -4, and then we added it back over. So x plus 4 equals 0. So this is my factor, right? X plus 4. Do you see how I left a space? I left a space for a reason, not because I just felt like leaving a space. Then my other one is x equals 1. Subtract it over, I get x minus 1 equals 0. What's the catch with the x minus 1, though? You have to have an exponent of 2. When you're done writing that, you're going to put your pencils down. Big time listening ears. If this was kindergarten, I'd be like, let's put on our listening ears. Ready? All right. I should teach kindergarten. It would be equally as bad as teaching English. Yeah, I'll teach them advanced calculus. How do you spell swelpe? You know, that's what I'll teach. They'll all come out not being able to spell any real English. Okay. Everyone's paying attention. Calculators down, pencils down. Everything is out of your hands. You're paying attention. Put down your ahem. Ahem. No. Don't type in your calculator. We're not there yet.
I just did.
I know, you rebel. All right. Jeez. Okay, let's go. You're not typing anything in. Like, we're going together as a team. I'm the leader. All right. So, if I go x plus 4 bracket x minus 1 squared. We watching? We press graph. We press graph, and by we, I mean me, and you're watching. Okay. Stop touching your graphs. There's going to be people who are not going to be able to do it without. Don't. Okay, following along? You see a graph in front of you? Yeah. Cool. We all agree that is a graph. Okay, we all agree that this graph has an x-intercept at -4 and 1. There's 2 of them, and this one looks like possibly a y-intercept at 4-ish. Okay? Watching. Not touching. Watching. I'm going to give the exact same equation, but I'm going to give it a leading coefficient of a different number. So watch. 2. X plus 4. X minus 1 squared. Have I changed my x-intercepts at all, guys?
No.
X-intercepts changed?
No.
No. Let's press graph. It was 4. It is now 8. How far art thou did that happen? I should not try to do Shakespearean. It didn't work out well. Okay. What is this? Children who have learned transformations? It's a vertical stretch. These are factors. That's a vertical stretch. What does a vertical stretch do? It affects the y. What's the easiest y to look at on this one? The y-intercept, which was 4. It got multiplied by 2, so now it is 8. Miraculous, right? Did it change my x-intercepts, though? No. Watch. I'm going to be a super rebel without a cause. Negative. X plus 4. No. -2. I want to be more rebellious. Okay. X plus 4. X minus 1 squared. Graphy graph. Oh, that baby's going down. Why? What did it do? Transformation-wise. Transformation-wise. It reflected on the what? X-intercept. My mouth is my x-axis. My mouth is not working today. It's like I'm like blah 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 blah. But in my head I'm saying x-intercept. Or like x-axis, but I'm saying blah 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 blah. Or swelpe. Oh boy. Okay, here's the x-axis. It's reflecting in the x-axis because we have that -1 in front, correct? And our x-intercept now is -8. Oh, how did that happen? I also multiplied all my y's by what?
9.
-2. We had someone who's answering correctly. So it changed them. So all of my y's changed. So what's the only thing that did not change? Why did my x-intercepts not change? Because they're 0, and I'm multiplying by y's by -2, and 0 times -2 is still 0. So, pick up your pencils, pens, whatever you want. Why did I leave a space here? I left a space here because you need to find out what A is. You need to find out what your vertical stretch or reflection, if they exist. Okay, you need to find that out. In 20-1, whenever I get to teach it, people will do all the work and not solve for the A every single time. Remember that when you type in the question, when you type in this equation, for example, here, without the A, and you press to look at the graph, they don't match. Because you didn't find the leading coefficient. You didn't find that there was a vertical stretch factor. Okay? So how do you do that? Your first step is to set up the factors. Your second step is to just take a coordinate off of here. And often they'll have one bolded. Never take the x-intercept. That will not work for you. I'm going to take the y-intercept, which is -0 and -4. So I'm going to take 0 and -4. And guys, a hint to you. If on the diploma there is a point bolded, it's bolded for a reason. You're probably going to have to use it somewhere. Okay? So now I just plug that in for my x and my y and solve for my a. So I'm going to get -4 equals a. 0 plus 4. 0 minus 1 squared. -4 equals a. And then it's 4 times 1, which is 4. Divide by 4. And my a equals what? -1. I even drew it, so that was a good one. Then I get people saying, okay, there's my equation. That's an equation? No, you just found a. Does a always have to be -1 when it's ending down on the right? It needs to be negative, but does it have to be -1?
No.
It could be 2, it could be 4, it could have a stretch with it as well, right? But this equation, this equation is y equals -1, x plus 4, x minus 1 squared. Now you should always walk away from every single time you've ever made an equation of a graph and know if you're right or wrong. Why?
Because you can plug that in.
You can plug that into your y equals, and you have a graph here. And look, it has an x and y axis already stated what it is, right? So I would type in my x min is -5, my x max is 5, my y min is -22, my y max is 14. I would literally make my window be their window, right? Now obviously this is a vertical window and ours is horizontal, so it's not going to be perfectly matching it, but you'll be able to see that it actually works, right? Okay, cool. They didn't ask for it in this form. I'm pretending we didn't ask for it in any form. They're going to ask for it in this form. What are we going to have to do? Expand it. So try that out. Then I'm going to show you an easier way. Now, what if I'm scared I did it wrong? You can type it into your calculator and see if you get the same graph, correct? Now, more often than not, they won't ask for it in this entire form. They'll say this. More often than not, they'll say in this form. So you still have to, you can't bypass this form, right? You can't bypass the front form, you have to do that first. But they'll say in this form, determine the value of A and D. Do I have to expand the whole thing to determine the value of A and D? What I have to do if I just want A and D If I want a, I multiply all of the x's plus whatever number's sitting in front. So if I want just the value of a, I would go -1. I need a different color. I would go -1 times x times x times x. And what do I get? Negative x cubed. If I want d, d is just the no variables, correct? So I multiply everything without a variable in each bracket. So I would go -1 times 4, which is -4, times -1, which is 4, times -1, -4. If you're asked for B or C, you have to expand it. There's no way, fast way to do that. But they'll often ask for the leading coefficient, so the A, and the D. Now, what does that D correlate with, guys? The y-intercept. If you're in standard, if you're in this general form, this is always your y-intercept. Which means if you're in an equation without brackets, this back number is always your y-intercept. So it would be at 0 and -4. This tells you how it ends on the right. So if that's negative, it ends down on the right. If your leading coefficient is positive, it ends up on the right. So what's this one? It's negative, so it's down. Let's check it out. Checks out, right? Wow, there's a graph to the right of this one. I wonder what I would want.
Do another example.
I want you to do it. Try it out. On the right. Yeah. The left changes depending on if it's cubic or if it's degree 1, degree 2, 3, or 4. If it's an even degree, so 2 and 4, they end in the same direction. Remember, parabolas end in the same direction? If they're odd degrees, they end in opposite direction, like linears and cubics. So this will only tell you how it ends on the right, and then the degree, which we're going to talk about tomorrow, the degree will tell you how it ends on the left. So if this ends on the right down, because it's an odd degree, I know it actually ends up on the left as well. But we discuss that more tomorrow. Can I draw your attention to this before you mess up? What is this happening? This is going through which x-intercept? 3. And if I want the minimum possible degree, how many is happening here?
3.
3, because it's doing that inflection. How many is happening here?
1.
What's 1 and 3?
4.
4. Oh, and they're in the same direction, so it's even. Okay? So try that one out. So this one, we know we have x equals -4. Nope, this would be negative. Sorry, sign of leading coefficient was negative. Forgot to write that on the last one. X equals -4, and then -4 is 0. And then my other one is 3. X equals 3. Make sure you put multiplicity 3. And then I have 3, 0. Okay, when I work those backwards, my factors are going to be y equals a. When I move this 4 over, I'm going to get x plus 4. And I could put it to the 1, but there's no point, right? But I could. And then this one, I'm going to move the 3 over by subtracting it, so I get x minus 3 cubed. And then I need a point to find my a. I'm going to use... They're not the best points. Okay? I'm going to use this one. Because this y-intercept isn't even very clear. Now I'm telling you, on a diploma, they will bold a point so that you're not like randomly guessing. So you guys might have gotten a different number than me because you've randomly guessed something. But like say they'll bold something like this, and then that's like screams, here's this point. Like if they bold a point, they're bolding a point to say it goes through that cross section, use it. Okay? So I'm going to use this one, which is 5, 8.
No.
So 5, 8, x, y. So I'm going to get 8 equals a 5 plus 4, comma 5 minus 3 cubed. So I get 8 equals a and then 9, and then 2 cubed is 8. So I get 8 equals 72a divided by 72. A equals 1/9. Am I done? No, the answer is no. Thanks, guys. You have to write it in front. And what is my leading coefficient? Positive, and so is that up on the right. So it's positive. And what was the least possible degree? Degree 4. And then we're going to flip over. Yeah.
For the first, how did you find D again? You're trying to do a shortcut?
If I want to find D, you just multiply all the numbers. All of the, and nothing with an X. Because D is my constant, it doesn't have a variable on it. So I just did -1, 4, -1, -1. Okay, we're flipping over. And we're bypassing this stuff because we're going to continue with this stuff tomorrow. And looking at graphs. But what I want you to do is go ahead to here. Example 6. We already know how to solve. So these are the questions that I want done for tomorrow. Because we're not going to do a daily quiz tomorrow, but I want you to practice. So solve number 1. Number 2. Three and 4. 4 of them. 1, 2, 3, 4. So the very first thing we're going to do when we get to class is we're going to go through and solve these and make sure you're right. Okay? If you don't attempt them, that's on you. That's not helpful for yourself, right? So why do I want you to do these? Because these are practice for what we've done so far. All we've done so far is we've factored and then solved, correct? If I ask you to solve, what am I making you do? Factor, then solve. So I'm making you practice the stuff we've done. Okay? So please go through and do 1, 2, 3, 4 for tomorrow, and that's the first thing we're going to do when we come into class. We're going to go through those 4, and then we're going to finish the last lesson.